Imagine you are standing on the shore of a small, unnamed island at the break of dawn. The fine white sand is still cool beneath your bare feet. The air warms around you. The sea is flat and calm, like dark glass reflecting a pastel sunrise. You take a photograph. Satisfied, you leave in your boat. That afternoon, the sky goes bruised purple. A storm arrives with a terrifying scream, wind howling. Colossal waves crash like battering rams. The next day the island is gone, only churning sea. This is not fantasy or a ghost story. These vanishings are real and documented. Islands can appear and vanish with shocking speed. The causes are natural forces and sometimes human error. We'll explore two famous cases: Gulf of Mexico, warm, hurricane-prone waters. Bermuda Triangle, the legendary, misunderstood region. We'll examine what witnesses saw. We'll examine what old maps showed. We'll examine what modern science now reveals. The story of disappearing islands begins on the brittle, yellowed pages of old maps. Long before the advent of satellite sonar, the craft of cartography was an intricate blend of science-art hearsay. Mapmakers in the 16th century had far less data than their modern counterparts. Mapmakers in the 17th century had far less data than their modern counterparts. Mapmakers in the 18th century had far less data than their modern counterparts. Their primary sources were the tales logbooks of sailors who had ventured into the vast, unknown expanses of the ocean. These mariners would report sightings of new lands, and cartographers, eager to fill the empty spaces on their charts, would dutifully add them. Sometimes these reports were accurate, other times they were the result of navigational errors, optical illusions, outright fabrication. These non-existent lands that haunted maps for decades, sometimes centuries, came to be known as phantom islands. One such phantom island appeared on a Gulf of Mexico chart published in 1692. It bore the ominous name Isla de las Muertas, the Island of the Dead. The map depicted a treacherous piece of land littered with the skeletal remains of wrecked ships. Yet despite its presence on maps for many years, no subsequent mariner ever managed to find this grim island. It existed only as an ink drawing on parchment, a ghost born from fear and imagination. Similarly, in the mid-Atlantic, charts often showed a place called Sandy Key, a fleeting spit of land said to appear only during the rarest of low tides before sinking back beneath the waves. In 1874, a French ship captain named La Fontaine recorded a detailed entry in his logbook about encountering a lush green island in the central Gulf of Mexico. He described it as having rolling dunes, flocks of seabirds, a sense of permanence. He and his crew watched it for several hours before a sudden, violent squall blew in. When the storm passed just 4 hours later, the island had vanished without a trace, leaving only the confused and unsettled sea. Then, in 1902, a British naval vessel was dispatched to search for a place called Atlantis Key, a location whispered about by local fishermen who claimed it was a real, though elusive, landmass. The explorers conducted a thorough search but found nothing but deep blue water. These tales, a rich mixture of true environmental events, chance sightings of temporary sandbars, simple human error, became the fertile soil in which grander legends could grow. The line between a temporary sandbank washed away by a storm and a mystical island that appeared and disappeared at will became blurred. Each new story, passed from one sailor to another in the dimly lit taverns of port cities, added another layer of intrigue and embellishment. These historical accounts are not just failures of old science, they are a crucial part of the human story of our relationship with the sea. Our first modern case study begins, not in the distant past, but very recently. In the year 2018, a fisherman named Carlos Hernandez was navigating the coastal waters off Campeche, a state in southeastern Mexico. He came across a small, previously uncharted barrier island approximately a quarter of a mile from the mainland shore. Low, verdant dunes, covered in tough coastal grasses, a flat, sandy beach. Recognizing its unique presence, Carlos took several clear photographs with his phone, documenting the island before continuing on his way. His return, however, would be delayed by the fury of nature. A few weeks later, a powerful hurricane, which would be named Odessa, churned its way through the Gulf of Mexico. The storm brought with it torrential rains, and a devastating storm surge, relentlessly pounding the Campeche coastline for more than a day. When the weather finally cleared and the sea calmed, Carlos Hernandez piloted his boat back to the location. But it was no longer there. His before and after photographs provided stark, dramatic proof. One image showed land. The other showed only water. This dramatic disappearance quickly caught the attention of local media, and subsequently, marine scientists. It was a perfect, real-time example of how quickly and completely a storm can reshape a coastline, underscoring the vulnerability of low-lying barrier islands. They are in essence dynamic ribbons of sand, waves, currents, winds. They act as natural buffers protecting the mainland from the full force of ocean storms, but they pay a heavy price for this service. Following the public interest generated by Carlos Hernandez's story, public posts and photos going viral, a team of oceanographers arrived. Coastal geologists joined the investigation. They set out to move beyond anecdote and build a precise scientific picture. They used bathymetric sonar. Sonar sends sound pulses to the seafloor. It times the returning echoes. Software builds a 3D map of the seabed. A research vessel swept the site meter by meter. Sonar scans revealed an elongated sandbank 10 to 15 feet below sea level. The ridge's S-shape matched Carlos's S-island photos. The island was the peak of a mobile sandbank, not rooted to the deep floor. Sand shifted by currents and waves can rise above the surface during calm periods. Scientists pulled decades of satellite imagery from NOAA archives. They made a time-lapse showing the sandbank rising and falling over 30 years. Some years it was a clear island with a beach. Other years it was only a faint light blue shoal under the water. The hurricane didn't erase the island geologically, it removed the top sand layer. Takeaway: many coastal islands are transient sand piles, not fixed land. Charts may show land that is no longer safe, or may not exist. Use modern tools. NOAA, Shoreline Change Viewer, check tide gauges, check hurricane surge models, be prepared with safety gear, carry a reliable GPS, always consult the most recent survey data. A single powerful hurricane like Odessa can carry enough energy to physically pick up an entire island's worth of sand and redistribute it across the sea floor, erasing it from the map in a matter of hours. Carlos Hernandez's photographs became a powerful visual testament to this raw and transformative power. Our second case study takes us from the tangible evidence of the Gulf of Mexico to the murky, legend-filled waters of the Bermuda Triangle. During the mid-20th century, the 1950s and 60s, a wave of sensationalism swept popular culture. Pulp magazines, radio dramas, early television shows. Within this environment, the Bermuda Triangle became a focal point for mysterious narratives. Vanishing ships, vanishing planes, a persistent legend. A phantom island that would appear and disappear in the middle of the Atlantic. Military radar operators at a base in Bermuda or a base in Florida had detected a mysterious solid blip on their screens where no land should be. The blip would appear for a few hours, then vanish. Survey teams were allegedly dispatched but found no land. The narratives were crafted to suggest conspiracy or phenomena beyond understanding. The stories grew more elaborate with each retelling. Secret government weapons, testing perhaps a holographic projection or a submersible platform. Others hinted at more supernatural explanations, connecting it to the lost city of Atlantis or extraterrestrial activity. Tabloid headlines. Floating island. The ghost isle of the Triangle. The ephemeral mobile island joined Bermuda Triangle lore as unsolvable evidence. Unlike the Gulf case, there were no clear photographs or verifiable eyewitnesses like Carlos Hernandez. Evidence was almost entirely anecdotal and sensationalized. It lived in cheap magazines and the scripts of radio broadcasters, not in the official logbooks of naval officers or the peer-reviewed journals of scientists. This lack of concrete evidence did not stop the legend from taking hold. The story was simply too good to let the facts get in the way. It was a perfect mystery, seemingly without an answer, which only made it more appealing to a world captivated by the unknown. The left side shows a small sandy island with sparse vegetation under a sunny sky, and the right side shows the same location, now just open, choppy water under a stormy sky. For decades, the story of the Bermuda Triangle's Phantom Island remained in the realm of speculation. Without tools to map the deep ocean floor, there was no way to completely refute the claims. However, the dawn of the 21st century brought with it revolutionary technologies that could finally shine a light into these dark, mysterious waters. Since the early 2000s, extensive hydrographic surveys have been conducted. These modern survey ships are equipped with multi-beam echo sounders, sophisticated sonar systems that can map the seabed with incredible precision and in high resolution. These multi-beam systems send out a wide fan of sound beams, allowing them to map a broad swath of the ocean floor with each pass. The resulting data creates a detailed, three-dimensional digital model, revealing every mountain canyon ridge. After years of systematic scanning, the conclusion is unequivocal. There is no large, permanent landmass or island hiding beneath the waves. Features once marked as possible land turned out to be shallow shoals, seamounts crests of moving sandbanks. The powerful currents here, most notably the Gulf Stream, play a significant role. This massive river in the ocean constantly moves vast quantities of sand and sediment, building shoals in one area while eroding them in another. With primitive lead-line soundings, a sudden shallow patch in rough seas could be misread as land or breakers, creating chart errors that persisted for generations. Today, the public has unprecedented access. Digital mapping portals let anyone compare mid-20th century charts with modern high-res bathymetry. Symbols for doubtful land often correspond to continental shelf features or temporary sand deposits. This direct comparison shows phantom islands were charting mistakes and misinterpretations, not supernatural events. The mystery dissolves under the bright light of verifiable information. So, why do islands actually disappear? The answer is not a single simple cause, but rather a combination of powerful natural forces, some of which are being accelerated by human activity. The first and most dramatic cause is storm erosion. Hurricanes, typhoons. Other large-scale storms generate immense waves and a high storm surge, which is a literal bulge of water pushed ashore by the wind. These forces act like giant bulldozers, scraping sand from beaches, pulling it from the tops of dunes. A low-lying barrier island, essentially a pile of sand, can lose a significant portion of its mass in just a few hours, shrinking or vanishing beneath the waves. The second major factor is global sea level rise. Since 1880, the average global sea level has risen by more than 8 inches, and the rate is accelerating. For extremely low-lying landforms like small islands, coral atolls, river deltas, even inches can mean permanent flooding. A third, more localized force is tectonic subsidence, shifting plates, compaction of soft delta sediments, or extraction of oil gas water. As ground subsides, land sits lower relative to sea, creating a double threat with sea level rise. Many islands rely on steady sediment supply. If rivers are dammed, islands starve and shrink. Dredging channels removes vast sand, destabilizing nearby shores. Jetties, seawalls, groins can block natural sand flow, protecting one area while accelerating erosion in another. Human beings love a good mystery. Sea monsters eating islands, kraken leviathans dragging them down, secretive agencies hiding islands or covering up experiments, ghost curses, portals to another dimension. Science, however, provides clear and testable answers. The rapid disappearance of an island follows known physics. Storm waves and surge can move millions of tons of sand in hours. Data from NOAA and university groups during and after major storms records dramatic coastal change. This data is public, peer-reviewed, and available for anyone. Many historical sightings are explained by Fata Morgana mirages, light bending to create distorted, elevated images, plus dead reckoning errors. Conspiracy theories crumble under global satellite coverage, commercial and public, monitoring Earth constantly. The compelling story of disappearing islands is ultimately a tale where nature's power intersects with human perception and error. The relentless forces of hurricanes, tides, and currents are in a constant battle to reshape our coastlines, now amplified by global sea level rise. Old maps were filled with sailors' tales, navigational mistakes, hopeful guesses, turning real environmental events into enduring legends. The Phantom Isle of the Bermuda Triangle, the Ghost Island of the Gulf of Mexico, were born from the same basic ingredients, a dynamic planet and our struggle to understand it. Today we have better tools, ship-based sonar to paint detailed seafloors, satellites to watch shorelines change, public databases to check the facts. With these resources, we can see what really happened. The mystery gives way to knowledge. We can confirm that a hurricane washed away a sandbank, or that a historical chart was based on a simple miscalculation. Open a browser and visit a historical map archive. Find an 18th century chart, Then a 19th century one, spot a small island or shoal. Open a modern satellite map or a bathymetric chart of the same spot. Note the difference. Has it shrunk, moved, or disappeared entirely? Learn how storms and currents move sand in that region. Share what you find. When plotting routes, cross-reference multiple sources. Use digital nav tools with real-time sounders, tidal models, satellite-derived bathymetry. Apps like OpenSeaMap and Navionics overlay NOAA's latest surveys to flag hazards and legacy errors. Q1. Can a true island disappear completely? Yes. Barrier islands and deltas can submerge for years or drown permanently if sediment supply lags sea level rise. Q2. How reliable are old maps? Treat them as hypotheses. Distortions and transcription errors abound. Q3. What modern tools track changes? NOAA's Shoreline Viewer, ESA's Sentinel-1, and QGIS let anyone monitor coasts over decades. The case of disappearing islands blends physics, geology, and legend. Subscribe for more deep dives. Share which vanishing island we should investigate next, and stay tuned for our next episode on the sunken cities of the Indian Ocean. If mysteries, true crime, and conspiracies keep you up at night, you're among friends. Like this video, drop your boldest theory in the comments, and subscribe for weekly deep dives into history's strangest enigmas. Until then, stay curious, and stay skeptical.